Hello student, now coming to the second question of the exercise 4.3 for the chapter quadratic equations. So the question second is find the roots of the quadratic equations given in question first above by applying the quadratic formula. So what it means is that we need to find the roots of the quadratic equation of all the quadratic equation which were provided in question first, but now we need to apply quadratic formula. So now coming to the first quadratic equation, which was 2x square minus 7x plus 3 is equals to 0. Comparing this quadratic equation with the standard quadratic equation, let me write the value for the a, b and c. So value of a in this quadratic equation is 2, b is minus 7 and c is plus 3. So as we need to apply the quadratic formula over these coefficients, that is a, b and c. So let me write first the quadratic formula, that is x is equals to minus b plus minus root b square minus 4ac divided by 2a. So this is a quadratic formula. Now just substitute the value of the a, b and c in this formula. So here I will be getting minus into minus 7 plus minus root minus 7 whole square minus 4 into 2 into 3 divided by 2a, and here a is 2, 2 into 2. So from here x comes out to be equal to 7 plus minus 5 divided by 4. Or I can write it as x is equals to 7 plus 5 by 4 and x is equals to 7 minus 5 by 4, that is taking the sign separately. So from here x will be equal to 3 and 1 by 2. So these are the roots of the first quadratic equation by using the quadratic formula. Now coming to the second one. So what was the second equation? The second equation was 2x square plus x minus 4 is equals to 0. Again writing the coefficients a and b, c value. Here a is equals to 2, b is equals to 1 and c is equals to minus 4. Okay, so now applying again the quadratic formula, that is minus b plus minus root b square minus 4ac divided by 2a. Substituting the values, here it will be minus 1 plus minus root 1 minus 4 into 2 into minus 4 divided by 2 into 2, that is 2a. So from here x will be equal to minus 1 plus minus root 33 divided by 4. As root 33 will be a rational number, so here x will be minus 1 plus root 33 by 4, that is separately writing this plus minus sign, or I can write it as minus 1 minus root 33 divided by 4. So these are the two roots of this quadratic equation, that is 2x square plus x minus 4 by using the quadratic formula. Let me write the standard form so that it will be more convenient to all of you. That is ax square plus bx plus c. So comparing this standard equation with the quadratic equation being provided in the question, we have obtained the value of the coefficient a, b and c. I hope this was clear before as well. Now coming to the third quadratic equation. So here the third quadratic equation is 4x square plus 4 root 3x plus 3 is equals to 0. Again comparing this quadratic equation with the standard quadratic equation, that is ax square plus bx plus c. So from here a is equals to 4, b is equals to 4 root 3 and c is equals to 3. And as we know, the quadratic formula says x is equals to minus b plus minus root b square minus 4ac divided by 2a. Now substituting the value of the a, b and c in this formula, so here x will be equal to minus 4 root 3 plus minus root 48 minus 48 divided by 2 into 4. Or I can write it as x is equals to minus 4 root 3 divided by 8. So from here x will be equal to minus root 3 divided by 2. So this is the root of this quadratic equation. But as we know, the quadratic equation always have two roots. But here we have obtained just one value for the root of x. So what will be the another root? So definitely the another root will definitely be again minus root 3 by 2. Why? Because the term in the root square the square root was 48 minus 48 leading to 0. So whenever such condition arises and only one number, or we can say one unique root has been obtained, that very root will always be a second root also for x. So this is a condition of double root, means the one root of x is minus root 3 by 2 and the second root will also be minus root 3 by 2 itself. Okay, now coming to the fourth quadratic equation. So here the fourth quadratic equation is 2x square plus x plus 4 is equals to 0. Again comparing this with the standard one, here a will be equal to 2, b is equals to 1 and c is equals to 4. So using the quadratic formulas, here x will be equal to minus 1, that is minus b, plus minus root b square, that is 1 square, minus 4 into 2 into 4 divided by 2a, that is 2 into 2. So here x will be equal to minus 1 plus minus root minus 31 divided by 4. Now from here you can clearly observe the term root minus 31, as this is a non-real number. Why? Because the negative in the square root leads to its non-real functionality of this number, and the overall number will be real only and only if all the terms, or we can say all the numbers involved, are real ones. But here we have encountered a non-real number, which is root minus 31. In higher classes, you will be learning more about this number, as this number is specifically called complex number. But for now, this is not our focus. But just we can conclude here that the number being formed will be definitely a non-real one, leading to no real solution of x, right? Means there will be no real solution for x, for which we can obtain the roots of this very quadratic equation. So this was about the question second of exercise 4.3. I hope this question is clear to all of you.